Well, this is John Black, super chemist, here to show you how to make some carbon dioxide. I know a lot of people, they see what is it, the vinegar and baking soda, and that makes CO2. I don't like that. I don't like anything where the acid, this is a nice, clean way to make it. Um, I'll show you how in a second here. I basically stole the footage from another video I did called making, how to make potassium carbonate. Uh, Basically just bubbled CO2 into some potassium hydroxide and then recrystallized. But anyways, I stole some footage from there to show you how to do it. I did want to show you the structure here. If you're into organic chemistry, you can see that carbon dioxide is actually two carbonyls. You see that? It's two carbonyls. So it does do a lot of reactions. In the example I'm going to show you here in a second, I have calcium hydroxide in the liquid. I can't show you me making carbon dioxide because it's a gas, you can't see it. So this way, it's visually you can see that it's reacting with the hydroxide to make a carbonate that's insoluble. And you can see that I'm actually making it. Alright, I want you to see inside the test tube I have baking soda or sodium bicarbonate. In this thing here, I have a saturated solution of calcium hydroxide. And this is how you test for carbon dioxide, by the way. I'm going to heat this up, and it's going to release carbon dioxide into there. But calcium carbonate is not very soluble. So when I bubble the CO2 through it, you'll actually see the precip coming out, so you can see what I'm talking about. And the formation of calcium carbonate will, come about. I want you to think about what I'm doing here. I'm just bubbling in carbon dioxide. That's an oxide. That's how you make a lot of acids. You can pump NO2 in and into water, and you get nitric acid. You pump the SO3 into water, you get sulfuric acid, etc. Well, I'm just bubbling CO2 into water. So what am I going to get? I'm going to get carbonic acid, H2CO3. What's inside there? We have calcium hydroxide in there, and we're making carbonic acid. And what do you get when you add an acid and a base? You get salt water. So we're going to get calcium carbonate, a salt. So here's the formula. If you have 2 moles of sodium bicarbonate, then you will make 1 mole of carbon dioxide. And you can see the molar weights. You need 84 grams per mole, but there's 2 moles, so you multiply that by 2, you need 168 grams to make 44 grams of carbon dioxide. Keep in mind, you only have to go greater than 80 degrees C. Although that might be too slow at 80 C. You might have some suck back when you're trying to bubble something through because it's not making it enough. Now, I made another video called how to make anhydrous carbon dioxide. And it's on a bigger scale because I need to use it for a Grignard reaction to make a carboxylic acid. Anyways, if you want to see it, I'll leave a link in the description below the video, and you can click on it and check it out if you want. If not, don't worry about it. Now this is the apparatus I'd make. I would put, you can see I got my flame. This is an oil bath. This would have my sodium bicarbonate in it, and I would raise and lower this and, put the heat on and up until I got it fixed at a nice slow rate of bubbling, right? Now what will happen is you will make your carbon dioxide and you will make your water. If you have this hotter than, use an oil bath, you can distill off the water so it won't interfere. And it'll come up here just like a Dean Stark apparatus, right? It's going to distill off the water, come up here, and now this is your water-cooled condenser. The water vapor comes up, it gets condensed back into water, and it goes into this pot instead of going back into the same pot, right? So this will stay dry the whole time. As you heat it, your carbon dioxide will come up. It's not going to be condensed, obviously. Put it through here. You see this graduated cylinder? I would put some kind of drying agent in there, you know what I mean? Like calcium chloride or whatever, magnesium sulfate, some kind of drying agent. Even anything. And I would cap this off, right? And your gas comes in, goes to the bottom, and then it has to travel through all that drying agent before it comes up to this tube, comes out, and then you can bubble it into your product. Now, another way you can do this, and always have a bubbler. I mean, a suck back trap. You know what I mean? When this comes out, you want to have a suck back trap in case this gets sucked back. It won't get sucked back into here. I didn't draw it because it's an obvious thing. It should be on every type of distillation type thing like this. But another thing you can do is you can see down here on the bottom, pretend this is coming out, right, and it went to your suck back trap. Now it's going into here. See, it's the same exact thing. You're bubbling it right into your liquid. You could have a balloon on here, right? This is a bob, you know, put a attachment on there with a bobbed end. When you do this, this is a technique usually you use for hydrogenation, but that's why I'm showing it. But carbon dioxide's so cheap to make, you wouldn't really do this. But if you did, you'd have to have a valve here and a valve over here. That way, as soon as you close this, like a second later, you can open this, and that way you won't have pressure building up in the system. Um, then this way you can leave this closed, right? You don't have to worry about suck back. You have your balloon on there. It builds up a higher pressure, even though it's just a little bit more pressure, but some because of the elasticity of the rubber. And obviously, then the gas will be more soluble in the liquid with the higher pressure. Um, Plus, you can see if it's reacting. Like as it reacts, the balloon will get smaller, right? Because the gas will turn into a solid or a liquid through this reaction, and the balloon will get smaller and smaller, and you'll be like, oh, the reaction's going forward. Is it really worth it? Carbon dioxide is almost free, so not really. I want my carbon dioxide because I'd like to bubble it into a Grignard reagent and make carboxylic acids. Um, there's a million uses for it. I'm sure I'll get to them, but that's one of the main reasons why I'd like to make CO2. Once you remember, keep in mind, always remember, science is great.